Welcome to my channel, children. Today we are going to discuss nomenclature of coordination compounds. To start with nomenclature, let us first learn name of ligands. Here you can see X minus. X minus is halo or halido. SO for 2 minus. Sulfato. You call it sulfato. CO3 minus 2. Carbonato. H minus 1. Hydrido. O minus 2. Oxo. From these names, it is very clear all the names of all negative ligands will end with O. NO2 minus nitrito N. Here N is written. If NO2 you write it as ONO, you name it as nitrito O. Because this nitrito can ligate either through N or through O. If it is ligating through N, then you write it NO2. If it is ligating to O, through O, then you write it ONO. So you name it as nitrito N, nitrito O. Such ligands are called ambidentate ligands. Now look at the next ligand, CN minus, cyano or NC, isocyano. These are also ambidentate ligand. Now look at the next ligand. This is a bidentate ligand. Oxalic acid is COOH, COOH. Remove 2 H plus ions, you get oxalate ion. The name of this is oxalato, or you generally represent it as OX minus 2. It is a bidentate ligand and its formula is C2O4 minus 2. Now next we can go through some neutral ligands. Aqua, H2O is aqua. NH3, amine. CH3NH2, methylamine, you can see. CH2NH2, CH2NH2, ethylamine, ethylene diamine or ethane 1,2-diamine. These are all neutral ligands. CO, it is carbon monoxide. In the ligand name is carbonyl. You call it carbonyl. And NO, you call it nitrosyl. Okay. So first you should learn the name of these ligands. After learning the name of these ligands, the next step is to learn learn how to calculate the oxidation state. To calculate the oxidation state, I have given here one example, K4FeCN6. You can see the example here. K4FeCN6, K is plus 1. Okay, so it is plus 4. Remove K means put minus 4 above the coordination entity. The square bracket is called coordination entity. Now we are going to find the oxidation state of Fe. So we are putting X plus 6 into Cn is minus 1 is equal to minus 4. Minus 4 is the charge of the coordination entity, so minus 4. X is equal to plus 2. So charge of Fe is plus 2. Now look at the next complex, CONH3 6 times, 3 plus. Here we don't know it is Cl3, complex is Cl3, you can see. When you remove 3 Cl3, you have to put minus 3 above, plus 3 above the coordination entity. So you are removing 3 Cl minus and you are putting plus 3 above the coordination entity. So the CO, the oxidation state of CO we don't know. So just put there X plus 6 into 0. Charge of NH3 is 0 is equal to 3 or X is equal to plus 3. So charge of cobalt is plus 3. Like this, you should know to calculate the oxidation state of central metal ion. Now we can start naming the ligand, naming the complexes. Now you can see the first complex, K4FeCN6. When you name complex, first start naming with positive part. Here positive part is potassium. So start with potassium. Potassium. Okay. Now I am going to write a potassium. The first name is potassium. Potassium. Now hexacyano. You can see here potassium hexacyano. Okay, 6 Cn is there. So if there are more than one ligand, you can use the prefix di, tri, penta. Here there are 6. So we are using the prefix hexa. Hexa. Cyano. Now this is a negative coordination entity. When the coordination entity is negative, the name of the central metal ion will end with ATE. If it is positive, the name of the central metal ion will be as it is. Okay, just keep that in mind. So here it is a negative coordination entity. So the name of Fe will be ferrate. Now, suppose if it was positive, the name of central metal ion will be iron. You will not write ferrate, you will write iron. Now, oxidation state we already calculated 2. Now, this oxidation 2 will decide K4. So, you don't have to write here tetra potassium. Only potassium is enough. Only you have to mention the oxidation state of the central metal ion. So, first positive part of the complex, then the negative part. If the negative part is coordination entity, name the ligands first. There are 6 ligands. So, hexa, cyano, ferrate. Because it is negative, the name of the central metal ion end with ATE. Ferrate 2. Okay. Now, let us go to the next complex. Look at the next complex. Here, I have used more than one ligand. And you can see coordination entity is positive here. Coordination entity is positive. Here NO3 is -1, you know. So above the square bracket, you will get +1. Okay. So this shows coordination entity is positive. It is written first. So in the coordination entity, we have to name the ligands. If there are more than one ligand, we name the ligands in alphabetical order. Here, amines. Amine come alphabetically first. So 4 amines are there. So we start the naming as tetra. We don't use T as in alphabetical order. Only the name of the ligand is used in alphabetical order. Tetraamine. When you write amine, the spelling, there are 2 M. Okay, keep in mind. Tetraamine. Then Cl will come. Chlorido. Tetraamine. Chlorido. Then NO2 will come. Nitrito. It is NO2. So we can write nitrito N. If it was ONO, nitrito O. Now this is a positive coordination entity. So we write it as, the name of the central metal ion will be as it is, chromium. Okay. Now oxidation state of chromium we have to find out. What is the oxidation state? We don't know. Here NH3 is 0, NO3 is -1, Cl is -1. So to get +1 outside, it should be +3. Just calculate roughly like that. Every time you need not put X and calculate. If you want to do that way, you can do. So oxidation state of +3 -1 will be +1. So oxidation state of chromium is +3. 3. And NO3 is nitrate. That you name as it is. Just like how we name a nitrate salt. Nitrate. So this is the way you will do when you have more than one ligand. Now you can see if there is a bidentate ligand. Different types, I will just name it for you. If there is a bidentate ligand, the rules are same only. Only one thing you have to keep in mind. You will use the, instead of ditri, you use the term bis-tris. Instead of di, you will use bis. Instead of tri, you will use tris. Instead of tetra, you will use tetrakis. Okay. So we start with the positive part. Here sodium. Sodium. 3 are there. It is a bidentate ligand. So we use the term tris. The prefix will be tris. Tris oxalato. And this is a positive ligand, positive coordination entity or negative. Sodium. Whenever it comes second, it is a negative coordination entity. So the name of the central metal ion will end with ATE. So ferrate. Ferrate. Now oxidation state. Oxalato, one oxalato as -2. -2 into 3 is -6. Fe, we don't know, X. Here there are +1. You have 3 sodium ions. So above the square bracket, there is -3. So what will X be? X will be +3. So oxidation state of iron is +3. +3 -6 will give you -3. So here in parenthesis, you put 3. That's it. Now we'll go to the next complex. Here you can see the coordination entity is positive. Whenever it is positive, it is written first. Whenever it is negative, it is written second. Okay. So here we start with ligand. In alphabetical order, ethylene diamine is there, bromine is there. Right. But here we start with bromine. Alphabetically, bromine comes first. So we start with bromine. 2 bromine is there. So name is not bromine, it is bromido. So dibromido. Only the name of ligand is done alphabetically. Bromido. Bis. It is a bidentate ligand. So bis. Two are there. Bis ethylene diamine or bis ethane 1,2-diamine. That amine has only one M. Ethane 1,2-diamine. Now it is a positive coordination entity, so we can write cobalt. Here no space is there, that is why I am writing it down. You have to write continuously without any space. All alphabets you should write continuously. Now what is the oxidation state here? Charge of En is 0, charge of bromine is -1. -1 into 2 is -2. So you have -2. Here sulfate is -2. So here we already wrote -2. Means here it will be plus. This sulfate, -2 of sulfate is written here 2. So here outside the square bracket there will be +1. So if it is +1, what will be the charge here? +3. Because +3 and -2 will give you +1 outside. Why I wrote +1? Because here I am having a square. Here it is there, that 2. That 2 is of this sulfate. -2 has come here. So definitely the coordination entity has a charge of +1. Because sulfate there is no 2. So here I am putting +1. So oxidation state of cobalt is +3. So I am putting here 3 sulfate. That like just as you name a sulfate salt you have to name. Now you can see here you have two coordination entities. How we will name it? First we will find the oxidation state. Give X oxidation state of cobalt plus 6 into charge of NH3 is 0 plus oxidation state of cobalt is X plus 6 into isocyano NC, it is -1. No charge above the coordination entity, so 0. X plus X is 2X. 2X is equal to 6 or X is equal to 3. So you know oxidation state of cobalt is +3. Now how we name it? First name the first coordination entity. Hexaamine. 6NH3 is there. So hexaamine. 2 times you will write A also, okay? That doubt and all need not come for exam. Hexamine, cobalt. It is a positive coordination entity. So I am naming it as cobalt. Cobalt. 3. Oxidation state is 3. Hexa isocyano. NC, no? So isocyano. It is a negative coordination entity. So it is, the name of the central metal ion is cobaltate. Cobaltate 3. So this is how you name it. Now why I told negative here? Plus oxidation state of NH3 is 0. So outside the coordination entity you have +3. Here oxidation state of CN is -1. So outside you have -6 plus 3 will be -3. So that is why I told this coordination entity is negative. So the name is cobaltate. First coordination entity is positive, name is cobalt. Now another way how they will ask for exam is, they will give you the name and you have to write the formula. Okay. Now when they give you the name, how you write the formula? Here you can see tetraamine aqua chlorido cobalt 3 chloride. So you know cobalt is a central metal ion. Open the square bracket. Put cobalt. Okay. Now tetraamine, alphabetically amine comes first, aqua then chlorido. Even the ligands when you write inside the square bracket, it should be alphabetically. So amine is NH3, NH3 4 times. Then aqua, only one aqua is there. So put one water, one chlorine is there. To put one Cl, close the square bracket. And then chloride Cl. Now how many chloride will come? We will decide based on the oxidation state. Here +3 they have given. So we will put here +3. NH3 is 0, H2O is 0, Cl is -1. So +3 -1 is +2. Here if it is +2, there will be Cl2. Now look at this potassium. First we will write K. Now open the square bracket. Central metal ion is zinc. Zincate, right? Zn. Tetrahydroxo. Hydroxo is OH. Tetra. Close the square bracket. Now, what is the oxidation state of zinc? 2. So, write here plus 2 minus 1. So, outside it will be minus 2. Then, here it will be K2. This is how you write the formula from the given name. Thank you, children. Thank you for watching. Here I have included some homework for you. You can see the homework. Do it in the comment box. You can put the answers. In the next class, I will give you the answers for all these questions. Thank you.